degree of dissociation. Degree of dissociation is a number. It's normally known as alpha, and it is between 0 and 1. And this shows the amount of substance that has been dissociated. So for example, let's say N2O4 is breaking down into 2NO2. You have your I stable. Now this you have to be extremely careful with. Okay, let's say I have 10 moles of N2O4. The dissociation is going to be minus 10 alpha. The dissociation is going to be a number derived from what you started with. So if I have 10, they have, let's say, 5%, so alpha is 0.05. Okay, when I actually work it as what dissociated, it has to be 0.5. For the NO2, I started with 0, and then it's going to be plus 20 alpha. So it's going to be, remember the ratio, 1 and 2. This will be 10 minus 10 alpha, and this will be 20 alpha. So that is the I stable. Okay, now let's assume for a second that the concentration here, or the volume here, is 1. So the concentration is the same as the moles. Okay, so for this, we see that Kc equals concentration NO2 squared over concentration N2O4, or Kc equals 20 alpha squared over 10 minus 10 alpha. At this point, you can simply just say alpha equals 0.1. Okay, so Kc is equal to 20 times 0.1 all squared divided by 10 minus 10 times 0.1, which will be equal 2 squared over 10 minus 1, which will be equal to 4 on 9, or 0.444 moles dm minus 3. Don't forget that you need to write the units. If on the other hand alpha equals 0.5, okay, then Kc is equal to 20 times 0.5 all squared over 10 minus 10 alpha, which is equal to 10 squared over 10 minus 5, which is equal to 20. So here we see that just by changing alpha, we can note we can find Kc. That is all the degree of dissociation. If on the other hand, you need to find the degree of dissociation, it's always going to be change. Okay, so degree of dissociation will be change over initial. And it's a number between 0 and 1.